RoadBond EN1 is used to improve the strength of base material and recycled in-place material. Field trials and lab tests confirm that soil treated with RoadBond EN1 is significantly stronger than untreated material, and that the strength improves over time. This allows reclaimed material and lower quality local base to be used for many projects that would otherwise require more expensive crushed stone base to be transported to the job site. RoadBond EN1 saves time, transportation costs, and natural resources. Lab tests, field trials, and over 21 years of general use speak to the effectiveness of RoadBond EN1. Hundreds of projects in differing climates, soil types, and construction methods have led to the widespread acceptance of RoadBond EN1 as a proven soil stabilizer. For example, TxDOT compared the strength of crushed limestone base with and without RoadBond EN1. TxDOT Class 1 base, by definition, must have an unconfined strength of 45 and a confined strength of 175. The untreated strength of this particular limestone base was 28 and 196 respectively. However, RoadBond EN1 improved the strength to 87 and 287 respectively. This represents an unconfined strength increase of 211% and exceeds the minimum requirement by almost 100%. In other lab tests, the Oklahoma DOT conducted falling weight deflectometer tests on a section of unpaved road in Comanche County. The results indicated a 50 to 60% stiffer roadway section where RoadBond EN1 was used. The photo illustrates the difference in the sections after 6 months. Also, Baker Shiflett Incorporated, an independent materials testing lab, described a 50% increase in CBR strength that occurred in a clay-gravel soil treated with RoadBond EN1. Many other tests have been performed with similar results by various testing entities. A comprehensive field trial was conducted by the Department of Transport South Australia and is worth noting. Since 1989, the Department of Transport South Australia has undertaken a program to widen and rehabilitate the Air Highway in South Australia. This highway was built in the mid-1960s to rural standards. The procedure for the trial was to recycle and pulverize the existing material to a depth of 325 millimeters. The material was then stabilized with RoadBond EN1 to improve the strength and quality. The Dynatest falling weight deflectometer was then used for post-construction evaluations to measure the pavement deflection. Using the Australian Guide to the Structural Design of Road Pavements, the maximum tolerable deflection for this 20-year road design is 1.0 millimeters. Deflection measurements were taken in the outer wheel path at 2-meter intervals over the length of the section beginning 1 month after construction. Additional measurements were taken every 6 months for 2 years. The average values for each measuring period are 1 month after construction, 1.09 millimeters, 6 months after construction, 0.80 millimeters, 1 year after construction, 0.68 millimeters, and 2 years after construction, 0.67 millimeters. Moreover, the resilient modulus was 380 megapascals at the end of the first year and 396 megapascals at the end of the second year. Incredibly, the section was stronger at the end of the second year than it was at the end of the first year. RoadBond EN1 is an innovative product that reduces common reoccurring failures. In summary, the benefits of RoadBond EN1 are greater strength, and the strength improves over time, more compaction and density, reduced swelling in clay soils, longer durability, increased load-bearing capacity, reduced permeability, less dust and erosion, and it saves time, money, and natural resources.